Screen is visible?
Yes, sir.
Okay. So actually we are into electrical control panel designing. Okay.
Sir, your screen not share.
Screen is not visible?
Yes. Visible, sir. I hope everybody visible.
Yes, sir.
Yes,
Yes,
sir,
sir.
visible.
Yes. Okay. So we are into electrical control panels, control panel designing actually. Into designing basically all these electrical design calculations like what will be the load current and how will be you select the switch gears for different applications like in MCC panels, how will we select the main contactors, switch gears, and all these things we will discuss deeply in the class actually. So today I will just explain what are the topics that we are going to explain in the next 45 days, next class actually. So this we will consider as a workshop for electrical, sorry, panel design. So designing of electrical control panels, mainly there are designing classes we meant to have a basic building blocks of designing, how we, what are the basic building blocks for required for designing of these electrical panels actually, though LT panels. So basically we used to discuss LT panels, only not LT panels, and we will discuss the basic grassroots. From the grassroots level, we will discuss how we will calculate the full load current of a particular motor, particular system, or a particular application. What will be the full load current FLC? What will be the FLC? And from the FLC, we used to calculate the switchgear, MCCB, MCB, and ACBs, and then we will design the particular control panels. Like there are different types of electrical control panels that we are going to discuss, which is power control center PCC and motor control center MCC panels, APFC panels, and AMF panels is there, distribution panels like lighting DBs and all these things, DG synchronizing panels, and combined with AMF panels will be there, and PLC panels. Obviously, we are not into programming part. We'll discuss just the designing of PLC panels and automation panels, AHV panels, and HVAC panels. Around 8 to 10 panels they are going to discuss deeply, and what will be the from the selection actually, from the basic switchgear selection to fabrication calculation, busbar calculations, and the powder coating calculations, and all these things. So we will just move on to power control centers. All of you know that power control center will be the main LT panels. From main LT panel, the power will be tapped to the PCC panels, and from there we will distribute the powers to different sections like MCC panel, APFC panels, and distribution boxes. All these things. From the power control centers, we used to distribute all these loads to the downstream panels. So power control center, how we will design the power control center, what will be the size of the incomer, what will be the size of the outgoings, and what will be the how to make GA drawings, general arrangement drawings, and IGAs, internal general arrangement drawings. All these things we will discuss, and I will show one IGA of PCC panel. This is the compartmentless double front main LT panels actually. Here we can see that there are different types of switchgear. ACBs are there, and 2 ACBs is there for incoming, and all the other ACBs are outgoing feeders actually. So this is the basic GA diagram of a PCC control panel, and how we will select the length, breadth, and height of the particular PCC panel that we will discuss, along with the frame size of the switchgears. Like ACBs, 800 ampere ACBs, there should be a particular frame size. And MCCBs also, there are 250 ampere MCCBs that will be a particular frames will be there. So all these things we will discuss, and how we will design a particular panel mm, for general arrangement drawing. What will be the length, breadth, and height of the panel, and for this, what are the criteria that you have to follow while designing the GA diagram? So what will be the cable alley size? What will be the incoming cable size? What will be the outgoing cable size? Outgoing incoming busbar size? All these things, current carrying capacity of the bus bar, aluminum and copper bus bars. So we designed this class in a particular way that we cover 99% of the designing of electrical control panels, like all these basic calculations like bus bar calculations, aluminum and copper bus bar calculation, what will be the current carrying capacity of a particular bus bar, and how will you calculate the size of the bus bar according to the current rating of the bus bar, and heat dissipation also. How much heat will be dissipated when a particular fault occurs in a LT control panels. So what is the amount of the heat produced and how it will be going to dissipate. All these things we will cover. We will design particular panel, and in our we used to give individual panel to our students to design, so that they can come across with different GA diagrams with different design, and so that they used to have a particular practical experience of designing panels. So this is the one of the compartmentalized panel for PCC. Next, we are moving on to MCC panels. All of you may know that MCC means motor control center. There are different types of motors available, like synchronous motor, non-synchronous motor. So all these motor, we used to design the starter for induction motors, actually, for AC induction motors. So how the motor is going to be started? Actually, by thumb rule, we used to calculate up to 7.5 we use DOL, and above 7.5 HP, yeah, 7.5 kilowatt. So we used to have star delta starters, but there are DOL starters, star delta starters, and even VFDs are there, and soft starters are there. So how we will be calculating, how we will be going to switch between star delta and VFD, or VFD to what we call soft starters. But how we will going to switch between these two starters? All these things we will discuss. Actually, we have to design a particular starter according to the applications, actually. So all of you may know that when a motor is going to be start, there will be a high current will be flowing through the windings of the motor. Then it may burn, or it may damage the motor windings, all these things. So we have to reduce the starting current. This is the main criteria for selecting a particular starter. But when we go deeply into selection of starters, then we will come across different types of different criteria for selection of starters. So some motors need a smooth starting and smooth stopping. Then we move on to we will select for VFDs. So VFD will have smooth starting and smooth stopping will be there, like conveyors. So all these MCC motor starters will be selected according to the application. What is the application? What is the machine? Which machine is coupled to the particular motor? Then that reveals the starter selection, actually. So if we if you have to select a starter for a conveyor, then the motor properties will be different. VFD starter will be there, so that we have to select VFD compatible motors. So VFD compatible motor means they should have class F insulation, and double earthing should be there. Shaft of the motor should be earthed separately. All these criteria is there for motors. And as well as we used to select those starters for this particular motor. So then we will select for the VFD starters. So MCC panels also, there are different types of starters and there are different criteria for selecting those starters. And we will discuss what will be the starter for a particular application. So VFD is using for a particular conveyor application, and for centrifugal fans there will be soft starters. Centrifugal fans means big fans having more than 1000 mm length of the fan blades, then we will go for soft starters. So the application, when the application varies accordingly. So that we are going to discuss, with that we are going to design as per the motor starters. This is a particular power diagram of MCC panel. Actually, it is for straddle the starter. Three conductors will be there: K1, K2, and K3. And one is for mains conductor, second is delta, and third is star conductor. So this is the typical power diagram of MCC panel. Next, we move on to APFC panel, automatic power factor control panels. So nowadays, this APFC panel is mandatory for all the industries, like to minimize the losses and to maintain approximately unity power factor. Earlier they were the MSCB or the electricity department is going to fine for lagging power factor. Nowadays they used to have lagging power factor also. So these can be attained by having an APFC panel as per the total load that you have connected to the particular system. So we will design a particular APFC panel as per the kVA rating of the generator or a particular connected load. Okay, so that we are going to discuss automatic power factor control panels, and this is the schematic diagram of APFC panel. There are so many capacitor banks are connected to the three-phase supply, and actually this is RTPCA. So both are there for lagging and for leading. Okay, so this is the basic schematic diagram for APFC panels, AMF panels, automatic mains failure panels. These panels are used to switch on the DG automatically when the main supply goes unhealthy. If the main supply goes unhealthy, if the main supply is cut off or going below the range, actually for three-phase supply, if it goes below 380 volts, then automatically the main supply will cut off and DG will start. So for that application, for that DG switching on, there is AMF controller, and for AMF controller we used to have a particular panel for controlling all these DG inputs and electricity board inputs. Okay, so these AMF panels take care of DG and it switch on and off when the main is unhealthy. So AMF panels we will discuss, and this is the power diagram of AMF panels, alternative side and main side, and here it is, the load is connected or here. And all these conductors will be switched on from the command of LVM, line voltage monitor. Line voltage monitor senses the supplied voltage from the main supply, and if it senses unhealthy, it will give supply to the alternator DG, and DG will switch on and the load sharing will be there, and then we will switch on the load. So what are the control circuit involved in these AMF panels? All this we will discuss. How we will select the mains conductor, how to select the generator conductor, auxiliary conductors will be there, AMF relay is there. What are the basic electrical connections of AMF panels that we will discuss. Next, we will move on to generators synchronizing panels. Synchronizing panels, all of you may know that by running a, two or more DGs in parallel, so we have to have synchronization of these two uh, generators. So DG synchronizing panels is used to club all these DGs, and then we'll use to share the load, and load sharing will be there. So particular application, there will be a DG synchronization. Both will be there actually, from auto application will be there, and for manual application. So both we will have this synchronous scope. Mainly we used to have a Woodward synchronous scope for this application. So Woodward synchronous scope having an LCD screen, and from there we can operate all these DGs also. Okay. So DG synchronizing panels. How we will, what are the basic criteria for synchronizing DGs? Voltage should be same, voltage phase angle should be same, and all these things we will discuss, and how we will switch on the DG after synchronization, and all these things we will discuss. This is the basic SLD4 synchronoscope synchronization panel, DG1, DG2, and DG3, and grid also. Grid can also be clubbed into this synchronoscope. From there, we can tap the load. HVAC panels, HVAC and AHV panels are there. So on these two panels will be discussed. Actually, HVAC panels, there are filters, back filters are there, and there will be centrifugal fans and damper open closing. How we will going to open and close the damper, and how we will start the thing, centrifugal fans. All these things we'll discuss as per the capacity of the synchronous panels, PLC panels, PLC automation panels. We will discuss the, we will design the input and output DIDOs, how much DIDOs will be required for selection of a particular PLC, and what is digital input and what is digital output, how we will select, what is the difference between analog input and digital input, all these things we will discuss. PLC control panels. This is a particular Siemens S7200 model PLC. The main topic is selection of switchgear. Actually, how will we select the switchgear? Normally, we used to select the switchgear as per the current rating. For example, if you have a current full load current of 250 ampere, then we will select a switchgear accordingly. For MCCB, it will be 250 ampere, or you will be selecting 315 ampere switchgear. Okay. For control application, control panel application, if we go deep into the selection of switchgear, then we will come across different types of switchgear selections, like current related selection, voltage related selection, and there will be a selection of accessories will be there, and there are different types of selection that we will discuss. How we will select a particular switchgear for a particular application. All these things we will discuss for that, and these are the, I will explain all these things. Uh, if you're having any doubts, then we will have a QA section for a particular presentation. I will show one more presentation for selection of switchgear. If you have any doubt in this particular presentation, then you can ask. Otherwise, we will move on to the other presentation, next presentation.
Sir, you have any drawings which you can show it electrical CAD, like control panel, or which you can wanted to share? Maybe your previous projects, sir. Let the students know something about that drawings of
One
control
second.
panel.
Yes, one second. Screen is visible? Can you see my screen? Hello?
Yes, sir.
Okay. This is a particular drawing. Actually, I had added this screen into the presentation also. So this is the basic GA diagram. So we can have this GA diagram. I will just zoom in. This is particular PCC panel actually. PCC panel, different types of incomers actually there. So this is the basic incomer, transformer incomer is the 3200 ampere ACBs, and APFC panel, APFC switchgear is there. And this is the basic layout of PCC panel now, J diagram of APC. So different types of switchgear as you can see. ACBs are the MTO type ACBs. MTO means mechanical draw type ACBs, and TPMCBs are there, MCB. And this is the incomer, so it will be EDO ACB, electrically drawn ACBs. And these are the outgoings like MCCB, 125 4-pole MCCBs. These are the basic front view of PCC panel. This is the top view of the PCC panel. Like you can see, for that incoming section, the depth has been increased so that we can accommodate the bus duct incoming section. So that particular portion, the depth is increased. And this is the bus bar flange details. All these things we have to design and we have to draft for that GA drawing. This is the particular GA diagram, and particular how the bus bar is going to be routing in a particular PCC panel, and we have shown like this. This will be the horizontal bus bar, and from that the horizontal bus bar we have tapped the individual outgoing feeders. So this is the basic bus bar routing for the particular PCC panel. Bus bar layout is there. SLD, single line diagram. Single line diagram, there is incoming supply, 2500 ampere in incomer LCBs. LCB is there. Okay. Then CTs are be connected, and from there the main horizontal bus bar is there for 3200 ampere current rating, 50 kA, breaking capacity 50 kA, and from that each NCBs or ACBs have been connected from the tappings. This is the single line diagram for a particular ACB, and this is the power diagram. Power diagram, it shows the various meters that we are going to use. There is indicating lamps are there. All these things. We just zoom in. This is for APFC panel. Like here it is showing on APFC. So for that, here it is the APFC capacitor bank, and indication lamp, RVB indicating lamp is there. Voltmeter, ammeter is there. Load manager. All these things we are going to connect for a particular metering chamber. Here we can show the metering chamber. Here voltmeter, ammeter, load manager, all these things are there. Annunciator is there. So all these indication meters, indicating lamps, all this will be in this power diagram. Space heater, particular application, space heater is requirement from the client, so that so we include the space heater and thermostat circuit for that particular application. So this is the power diagram of the particular PCC panel. Yes, sir. Rohit, sir, I am done. Hello. Hello. Am I audible?
Yes, sir,
Hello.
audible.
Yes, sir.
Rohit, sir is.
Yes, sir. I'm available right now, sir. Yes,
Yes,
sir.
yes.
Join.
So, I am done, sir.
Okay. Thank you, sir. Basically, the idea of the just I'm just sharing my screen. Huh. The idea of this workshop is like to have interactive sessions with the Bosky George sir, who is your trainer. So we have designed a course like those who wanted to do a strictly they have wanted to make a career into electrical design, which is which one of the important component is a control panel design. So we have like what is the topic which we are going to cover in this thing. I'm just going to show that presentation. Like mhm. So this is specially designed topics which is covered by which is taught by Bosque sir, and this will not be able to see this screen everybody.
Yes, sir.
Fine. So this is specifically this is a topic which or syllabus or content which is designed by Bosque George sir, who has a rich electrical LT panel designing experience also and training both. He has trained a lot of candidates from us, and I can show you the syllabus content which we are going to teach about. This is like just a second.
One second, sir.
Basic electric.
Hello.
Yes, sir.
I will share the screen for the syllabus.
Okay, fine. So you can share that screen, sir, and thereafter, I'm just stopping this here. You can share. You can share this content.
All of you can see my screen?
No, sir. No, sir. Yes, we are able to see. Thanks, sir.
Okay. This basic electrical calculations will be there. Full load current, how we will be calculating the full load current of a particular system, like as we discussed, like APFC panels, PCC panels, and MCC panels. That will be the full load current for a particular motor and particular APFC. Okay, so how we will be calculate the full load current FLC and power factor calculations. How what is the particular power factor calculation, how we will be improving the particular, for example, if you're having a 0.7 power factor of a 400 kVA system, so how we will improve the particular power factor from 0.7 to 0.95 or 0.99. So how we will be calculating all these power factor value, improve the power factor value, how we will be calculate the capacitor value, kVAR value of a particular capacitor, how much capacitor should be added to the particular system to improve the power factor from 0.7 to 0.99. So all these things we will discuss. Total connected load, selection of motor starters. We discuss how we will select the motor starters from DOL, star delta, VFD, and source starters. How we will be going to select selection of switch gears, like we discussed current selection, voltage related selection, and accessories related selections. All these things. Power factor correction method. We just discussed how we will select the particular power factor. So first, basic electric calculations, all these things will be covered. And next is the type of electrical control panel, 8 to 10 panels that we discussed, MCC, PCC panels. 8 to 10 panels will be discussed separately. And preparation of GA drawings. Like as we had discussed, as you are I showed the GA diagrams of PCC panels, sizing of various compartments in particular panels. For example, if you have a 800 ampere switch, ACBs or MCCB, what will be the length, breadth, height of a particular feeder for 800 ampere switch, and what are the components that feeders will accommodate, and all these things we will discuss. Non-compartmentals and non-compartmental panels will be there. Sizing of cables, sizing of cables and cable entry is a very important part actually for selection of the sizing of the cable alley and busbar alley. We require the size of cables, incoming size of cables and outgoing cable sizes. All these things we will have, we will discuss, and how we will selecting the sizing of the cables will be there. Busbar routings, as we are discussed, as you are seeing that how the busbar is routing in a particular PCC panel. From the horizontal busbar, the busbar is tapped from horizontal busbar and given to the outgoing feeders. So all these things, busbar routings, how you calculate the busbar routings will be there, cable terminations. what are the precautions you have to take care when the cable while cable termination work is going on. All these things we will discuss. Preparation of fabrication drawings. Ingress progress, actually. Ingress protection means if the panel is going to be installed in outdoor area, then what will be the ingress protection? And if the panel is in indoor, then what will be the ingress progression? IP protection classes, IP65, IP45, and where these IP45 panels will be suitable, IP65 panels where will be suitable. All these things we will discuss. Switchgear mountings, ACBs, how the ACBs are mounting in a particular panel, and for mounting an MCCB, what are the precautions, what are the arrangement has been done for particular mountings, all these things, cable support, busbar support, all these things we will discuss. Fabrication of particular panels, what will be the weight of the panel without switchgear, without busbar, and what will be the weight of the MS, mild steel, that we are going to use for a particular panel. So all these things we will discuss. Calculations will be there. Powder coating process. 7-tank process will be there. Pre-treatment 7-tank process will be there. What are the 7-tank process? All these things, bending as per IP protection. If the panel is going to be mounting in outdoor area, so what will be the bending as per IP protection classes have? What are the criteria for having dust bending? There will be 20 mm bending, there will be 5 mm bending, and there will be 3 mm bending. And so where these bendings are we going to use all these things. Discuss current carrying capacity, bus bars, total weight of the bus bar, rating of the bus bar as per current carrying capacity. For example, aluminum, it will take around, calculation purpose, we have to have 1 ampere per square mm, 0.8 ampere per square mm for aluminum. Copper, it will be around 1.2 ampere from square mm. Okay. So all these things we will discuss, and total weight, rating of bus bar, all these things. Power and control diagrams. As you have seen the power and control diagrams of particular PCC panels, MCC panels. So how you going to design those drawings, design those starters, design those feeders. So all these things we will discuss. These are the particular topics that we are going to discuss in next 45 days. If we start from next week, maybe that Rohit sir will be discussing when the class will be commencing and all these things. So this is the basic syllabus that we are going to cover in next 45 days. Yes. Yes, Rohit sir.
Yes, thanks, Boske sir, and most important, thanks all the participants, those who are here to know some valuable inputs from Boske sir. If you have any doubts, Hindi, English में भी बात कर सकते हो. Sir is also comfortable, but this batch we are going to make it in English because with me, Mr. Syed has joined, engineer Syed Moore. He's from South Africa. I think Syed, are you there, Syed? Hello, Syed. Syed, are you there? Syed? You make up a habit of muting and unmuting. Okay, because already we have enrolled few candidates. Syed has confirmed, and he is very serious, interested to learn for control panel design. The course he was really searching for, he was across globe, he was able to find us. And basically, no other training center provide this kind of course. Nobody, industry experts have so much. They have experts, they don't have a time. And we are thankful to Mr. Boske sir, who is delivering such enchanting trainings. And I speak English and from Turkey. Yes, me too. Okay, thank you. English is okay. We are going to make it English also. And those who are not also even comfortable in English, we can have you can have later on these sessions, you can have talk in Hindi also if you wanted to talk to, or you can type message. So we wanted to make interactive this control panel design course. I wanted to show the feedback. Right now I'm at my physical center. You can see at my Pune physical center, the Google location I've shared. It's 9:11 in the Indian Standard Time. And sir has been training with us, this center I'm talking about, since more than you can say a decade. Sir is teaching because he loves teaching, he loves sharing the knowledge, which no industry person, maybe is so comfortable in sharing his knowledge in a nutshell. In a nutshell, we have designed this kind of course, And I can show you the feedback, the sir feedback, which you can see the online presence also. Just I wanted to show you some of the feedback. Just a second. Is Mr. Bosque George? You are able to see this PPT, please, everybody? Yes, no?
Yes, sir,
I
yes.
can see it.
Yeah.
Yes, I can see it.
Yes, you can see. So this, you can see the feedback of the students who have done a course with us maybe 4 years, 5 years ago. Kiran Kokre, he mentioned, I have joined Sunday special batch on electrical CAD and control panel design, well experienced industrial, cleared all doubts with all better skills, I get promoted. So he was the person, Kiran, right now he's an entrepreneur, he started his own firm. He learned this training control panel design course with Bosque sirs 5 to 6 years back before COVID. He was Mr. Abhishek Kole. He has written very good tutor, flexible class timing and management, current job, complete support from the team, very good experience in learning electrical AutoCAD and control panel design by 18 peers experts. Means Anupa, if you can say, excellent providing by Kunjan and Bosque sir. His name also written, Bosque George sir, the person right now. His 2018 feedback, Just Dial, if you see, search in a Just Dial Sulekha, Google, you'll find his name. Ample reviews and genuine reviews. Friendly nature of people who teaches, good support from Rohit sir, me. And placements coordinator during that time, Projekta Shushma. Thanks all team. I've joined Sunday Electrical Card. So this is a fantastic. Bhupesh was the person, his company told that he go and learn the control panel design. He somehow come across to us like the person Syed has from South Africa joined. Similar Bhupesh, he come across, his company told me during 2019. I mean, 2000, it was 2018 he has learned. It's 8 January 2019. His company simply told, will increase the package of 2 lakhs to 3 lakhs rupees if you have learned control panel design with us. We have, this is a very genuine reviews. People wanted to share this people's numbers. We are ready to share. Excellent training in AutoCAD and control panel, supportive management, recommend to join. This is the genuine feedback. And most important is support, you already know, because some of our students who has already doing various courses with us, AutoCAD, E-Plan, control panel, a lot of pieces. So we give a sir is also going to share you the industry projects also who has already executed the projects. Being as a theoretical things which you cannot do, we are going to cover online theoretical technical things like in Excel, load current calculations, and all these things will be covered. The actual side things, we are not here for a blue collar trading blue side. You can do it. So this sir will provide you the previous maybe a industry exposure, what he has done, the calculations, the projects he has done, real time or previous, you can say. Those who are, you can see a freshers, we give a job calls also guarantee, CV writing, CAT test, technical interview preparations also. This support benefits. Next rejoining completely free. Within 12 months, that should be like this would be 9th batch. We have been doing every month, every year, every 2-3 months, we start a new batch of control panel design. So since COVID time, this would be 9th batch. Next rejoining free live doubt session, industry guidance, because this batch is not a 1 month process. It takes almost 1.5, 45 days to 50 days. And every day, Monday to Friday, online hybrid mode, this doubt session, no charges. Even we are here to support you 2 months, 2 years, 10 years, no charges for that. Just we have to come, whenever there is a batch going out, always welcome. But suppose if you wanted to have a doubt, just you have to ask the link with me or the management. So we connect between employer India, those who are in India. If you have a better skills, you have a better job. If you have seen in Naukri, Monster, whenever India international jobs, wherever you see there is a HVSA panel, blah blah blah, whatever it may be there. So definitely this is a skill set which is required. Companies are also looking forward, like they require in job system, electrical control system, hardware drawings, experience will be prevalent. However, fresher will also, they have in a mind, if they don't have they cannot, because it's not only for company, also the organization also sometimes difficult to hire somebody because of high cost of the employee. So what they does, they hire you, people like you, train them, means those who have already done the courses with them, and they expect to perform there with their senior or guidance. So these are some of the requirements. You see in Pune also there is a Siley Electronics. They are into LT control panel. They also required for electrical design. They have AutoCAD plan, blah blah, bill of materials, but they are into control panel designing also. This is the person UL Group also. They required AutoCAD electrical. Workflow automation, yes. Control panel design, AutoCAD electrical, all. You see, these are E-plan requirement, AutoCAD, but here you can see import export of PLC, internal layout. I am not. It's. I think that part is I am not showing you, but this is also one of the company which is into design electrical engineers, and they require E-plan. But here is helping switchgear manufacturing companies. They are also into E-plan also. Here you can say the hardware engineering inputs. Yeah, here say 12 number. Selection of switchgear component, MCB, MCCB, MCB fuse wire, relays, contracted drive for, see, this is a job description which you can put in your CV also. Once you have learned the course, estimate of panels required based on the knowledge and inputs given. They require E-plan. But they are into panel manufacturing, use E-plan. They are also required theoretical concept also. So especially those who have done, or this is always add-on things which you've required, which you are able to get through a nutshell in a 45 days. A person who is going to deliver, who has learned or who has done experiment with his hard work and his experiment, he is going to deliver that knowledge to you. And consultancy also later on also means consulting is guidance also if you required in your current job, or if you are an entrepreneur or a student or working professional, whatever it may. So you can see, understand all typical wiring, power diagram, input diagram, blah blah blah. So this company premises control panel solutions, they also require AutoCAD, electrical CAD, part-time, blah blah. So a lot of clients are working with us. We are, after completions, we also give a default certifications. CADDES would be, if you have done 2-3 courses, we give a certification also. And thereafter, we are also associated partner of CADDES through Autodesk. So if you look forward, Autodesk certification, nominal charge as if not today, 2,000 rupees extra. Those who wanted to, you can pay and get that certification through us also. CADDES also certifications. Those who wanted to enroll with this course, would be like to, most welcome. It's a time to reskills and upskills themselves. This is my WhatsApp number 8793166470. Syllabus I'll share. I think I have already shared to you. And any questions, queries, you can just discuss to me. If you have any queries, you can discuss to me, please. Or you can have any technical questions, because already people have enrolled with this course. So we are going to start a batch Friday. Sayed, we are going to start a batch day 1 from Friday, 8:30 p.m. same time, the time we have joined. And let's see if somebody joins who are able to grab this opportunity. Most welcome. Else we are going to start for you or 2 students, even if they are enrolled with us. Anybody, any technical question, commercial questions, you can discuss to me. The time would be 8:30 to 9:30 Indian Standard Time. Anybody else? We are going to end the meeting in next 5 minutes. Anybody, feel free to ask. You ask, sir. You don't have to pay anything. You can ask anything from the Bosque sir. If you have any kind of consultations required, what is scope, opportunity, whatever it may be, you have. Anybody? Yes, Sayyid, you have questions, something you can ask, because he is your tutor, or you say, Sayyid?
Yes. Can you hear me?
Yes,
Hello,
yes, Sayyid.
Yeah.
Yes,
First, I wanted to thank you. How well you are just doing, because just I have searched this course from the internet, and I have got the only institute who offering this course. I want to thank you, and I will see the result within the coming 45 days. How you are genuine, how you give the course, how you everything. I will see it, and then I will give you my last satisfaction when I finish this course. And also, I am electrical engineer working with through an 8 year. I'm working, and also I am a distribution director, low voltage. So just I wanted to see maybe I will see your course, and also and how just the course outline is a very attractive, and it's a very industrial. Anyone who can learn this course full, I think he can be professional. This this sector. So just everything is good, and I welcome. And also my medium is English language. Sometimes Hindi, they can speak Hindi, but my medium is only English language. So thank you very much. Thank you very much. How well you are just stood to teach the young generation is to become a professional. Thank you very much, my dear.
Yes, yes. Thank you, sir. Thank you for the feedback. Yes, yes. Thank you.
Okay.
Thanks, Sayed. He is an actor and he's also, learning is never ending story. And very thankful, Sayed. Across you have India, so many kilometers, more thousand kilometers you are away, but you have trusted us and you have already taken action. You have paid the fees. We are very thankful, Sayed sir. In spite of not knowing me, not able to, India at our physical locations. You see, in a Pune, we are sitting in Pune. We are the cheapest, or let's better because we are less expensive. India has a less expensive scientists, less expensive engineers, and because of which we are able to deliver such expertise. And globally, we are teaching globally. It's not only India. Now we have been present only in India since 10 years. I have been sitting in the same building. And believe me, we are getting reference not in Pune. We are getting reference if Syed has so many juniors, colleagues, or a lot of people from Dubai has joined. They are giving reference. We are able to just because of COVID, we have also shifted to online, and we are very thankful people who are searching for us and to get some alignment of the new knowledge which is required. And thankful people for taking actions. Anybody you have any technical questions, Syed, you can ask Boske sir. He's the right person sitting, and I'm very thankful to say yes, Boske sir. Uh, yes, Sayed. Anybody you can ask. Not only Sayed.
And just I have seen your course outline, but maybe there is a one thing maybe that's very important to cover. That's the bolt. Maybe when you are designing or just you wanted to do, maybe just you are connecting two bus bars, and those connecting when you are connecting to two bus bars, there is a bolt. Maybe when you are designing a bus bar which can carry 1,600 ampere, maybe you connect two bus bars with a different. So just maybe there's a bolt. Maybe that how to use that bolt is also very, very important. Which bolt you take it, that bolt can carry it for that ampere. And maybe and I have didn't seen your course outline for that bolt. Maybe how to use the bolt. Maybe the bus bar and the bolts are very important when you are building a panelist.
Yes, yes. Actually, when we selecting the bus bar, actually, so for example, we can say if you select a bus bar for 1000 ampere, we can go for 100 by 10 bus bar size, and similar to that bus bar capacity, we can have two run, for 100 into 10 into one run for that 1000 ampere will be easily carry, and for say 50 into 10 into 2 runs, that also we can select for that particular application. For that we have to interconnect these two 50 by 10 bus bar by a particular bolt. So that bolt have to withstand 1000 ampere. So we will design particular bolt so that it will carry 1000 ampere without heating. So that we take care. We will design for a particular interconnecting bolts, interconnecting bus bar. All these things we will design. We will discuss how to design particular bolt and particular bus bar. Okay.
Okay.
Fine,
Okay.
we'll cover Sayed sir.
You got it. My point is, and also you are fair. I will welcome for you. That's very important because just if you just connect two bus bars with a bolt that cannot carry for that ampere, maybe it will
Yes.
hit, yeah, and it will
Yes,
damage
yes.
for all the process.
Yes. Yes, I got your point that we will discuss, that we will design.
Okay. Okay.
Yes,
Thank
yes,
you.
yes.
Okay.
If you have any queries, we are going to start a new batch. So Sayed has already from South Africa he has joined. Anybody, Boske sir will take the session, Sayed. Even if somebody does not join, we are going to execute your class. Okay. So instead of tomorrow, we'll start again day sessions from Friday, and then Monday onwards, Monday to Friday we'll have. Okay, everybody. Same time, the time which you have joined, Sayed. Okay. Okay. Then we can end the meeting, sir. Anybody?
Okay. Yeah, it's okay. And this time it's very nice. This time it's very nice. It's
Final,
good.
right? So,
Okay.
okay, fine. Chalo, thanks. And also, it's would like to, if you've taken a serious, don't try to skip the class. Try to be regular for at least 40 days. I mean, you can say 4 to 6 weeks required, and some 4 to 5 days we conduct in a week. So someday, if sir has some urgent work, might be someone, but 4 to 5 days I'll notify everything. We'll create a WhatsApp group. If 2-3 people are there, we create a WhatsApp group, and it is notified in WhatsApp. Okay. Okay, thank you, Bosque sir. We are ending the meeting. Thank you. Good night,
Thank
everybody.
you.
Thank you.
Yes.